Okay. Okay. Jika awak tengok based on the note that I provided to you, okay. So this is the equation, okay, to determine the elastic settlement or immediate settlement for sandy soil, okay. Wait. Okay. So so the first C, okay, C1, okay, C1 based on this 4.5A equation, okay, where the Q is the what we call as the stress, okay, from the surface of the soil, okay, to the bottom of the footing, okay. Then we have another Q naught, okay. So this Q naught is the stress applied on the foundation or on the footing. Okay. So that is for the C1. Okay. Then we have C2. Okay. For the C2, okay, you may put the time, okay, based on the question or based on your prediction. Okay, your own prediction. Okay, for example, if you want to predict for 5 years, then you put 5, okay, in these C2 equations. Okay. So Isaac as delta Z we may discuss later. Okay. Okay. Then normally, okay, for this ground investigation work or soil investigation work, okay, we may use either CPT or SPT, okay. But I will not discuss in detail, okay, what is the equipment, okay, that usually used to carry out or to conduct for the SPT or for the CPT. Okay, so the value obtained from the SPT is number of blow, which is N. Okay, while the value obtained for the CPT is the resistance or the friction. Okay, and normally it measured by stress. Okay. So in order to obtain or to get the value for the Young modulus, okay, for example, for this ES, okay, then we should multiply with the 2.5 times QC, okay, if we are using the CPT value, okay, which is for the square and circular foundation, okay. Then we have ES for the street footing, okay, which is 3.5 times QC. Okay, so that is to get the value for the Young modulus based on the CPT. Okay, okay, for the SPT, okay, so this 766, okay, should be multiplied with the N number of blow, okay, then we may gain the ES or the Young modulus. Okay, okay. While for the Isaac, okay, we may refer to this diagram, and it is based on the type of the foundations. Okay, so if square and circular footing, okay, so we may follow to the solid line. Okay, so this solid line, okay, when the depth of the foundation, okay, is located at 0, so then the Iz value is 0.1. Okay, while if the depth from the foundation footing, which is B over 2. Okay, for example, if B is 3, so B over 2 will be 1.5. Okay, so the Iz is around 0.5. Okay, then if it is 2B, okay, which is if 3, so it will be 6, and while the Iz is become 0. Okay, so that is for the square and circular footing. Okay, meanwhile, for the street footing, where we follow the dashed line, okay, 0.2 when the Z is equal to 0, or which is at the depth below the footing base. Okay. So 0.5, okay, when the Z is equal to B, okay, and Z will become 0, okay, IZ will become 0 when the Z is equal to 4B, okay. So basically the definition of the strip footing, okay, where the rectangular footing width length over B is more than 10, okay. So that is the definition of the strip footing based on this Sherman diagrams. Okay. Okay. Ada soalan boleh tanya Yang saya dah pergi jauh nanti awak baru tanya. Saya pun nak ulang balik, ambil masa lah. Okay. Ada tak ada? Kalau tak ada saya proceed Okay, so saya proceed. Okay. So kita tengok this example Okay. So a shallow foundation of a size 3 times 3 meter in in plant is constructed at the depth of 1 meter in a deposit of sandy soil. Okay. So apa maklumat kita dapat? Okay. Dia ditanam pada kedalaman 1 meter. Okay. So definitely this will be the case for the sandy soil. Okay. So and it is a square type of footing. Okay. So the foundation is carrying a column load of 1,500 kilo newtons. Okay. So this is the load, which is the capital Q. Saya boleh tulis ni. Okay. And the unit weight of the soil is 18 kilonewton per meter cube. Okay. The question is determine the settlement of the foundation after 5 years. Okay. So dia beritahu 5 tahun after construction using the Sherman method. If the Young modulus of the soil can be estimated from the result of SPT shown below. Okay. So we need to determine the Young modulus, which is the ES. Okay. So based on this SPTN value. Okay. So tadi saya dah beritahu SPTN value. So for this SPTN value, okay, to get the ES, we should multiply with 766. Okay. Okay. So so how to determine the immediate settlement? Okay. So we look on the solution. Okay. So okay, this is the diagram. Okay. Of the SPT. Okay. Versus the foundation depth. Okay. Versus the depth of the depth below the foundation base. Okay. So based on this result, okay, saya kena lukis macam mana. Sekejap saya buka cara lain. Sekejap. Alamak. Saya tak lukis lah. Sekejap. Kita apa saya terang nanti awak boleh ni boleh faham je. Okey. Okay. Yeah, when we refer to the table P4.4 ni, okay. Okay. So based on the table P4.4, okay, the information that we can gain, okay, is based on the depth, okay, for every 1 meter, okay. So this is the SPT value, okay. So in the question that stated that the depth of the foundation, okay, uh, is starting from the 1 meter from the surface level, okay. So dia berada 1 meter di bawah surface level, okay. So means that, okay, uh, based on the SPT value, okay, so this value of 1, okay, will become as 0, okay. So ini akan jadi 0, okay. So this will be 1, 2, 3, 4, 5, 6, okay. Because for the square footing, okay, so the IZ, okay, the value for the IZ, okay, we may use up to 2B. Okay, so for this case, 3 times 2 will become 6. Okay, so we need to use the information up to 7 depth, 7 deep. Okay, 1, 2, 0, sorry, 0, 1, 2, 3, 4, 5, 6. Okay, so for the depth of it from the surface, okay, so we will not use the end value, okay. So only the influence depth is up to 6 meter deep. Okay. So this is the plot, okay, for the SPT value, okay, 6, 9, okay, and then goes to 10, 8, 12, 13, and the last one is 17. Okay. So why for the IZ? Okay. So actually they should construct for a 3 axis graph. Okay. So this should be IZ. Okay. And should use the different scale with the SPT. Okay. So for the IZ, when the value of Z or value of the depth is 0, so the IZ is equal to 0.1. 0.1. Okay. So when the value of the depth is b over 2, which is 1.5, okay. So the IZ is equal to 0.5, okay. And the last one, okay, if the depth is 2b, so the IZ will become 0. Okay. Okay. For me, it is better to group into 2 major group only. Okay. So, but for this case, okay, they group into 3 major groups. Okay. The first one is from 0 to 1.5, okay, meter deep, okay, and 1.5 to 4, okay, and then 4 to 6, okay. Okay, so 1.5, 0 to 1.5, okay, which is 6 to 9 SPT value, okay, and then 1.5 to 4, which is 9 to 8, okay, and the last one is from 9 to 12, okay, so the last one is from 12 to 17, okay, so they group into 3 major groups, okay. If you want to group into several groups, okay, the problem is, okay, you need to determine what is the value of the IZ at a certain depth. Okay. For example, from here 0.1 to 1 0.5, okay, it is very straightforward, and then you can get the average. Okay, awak boleh dapat purata 0.1 plus 0.5 divide 2, so 0.3 is the IZ. Okay, but from here 0.5 to the depth of 4 meter, okay, so you need to use interpolation, okay, to get the value for the IZ for the 4 meter below the floating base. Okay, so yang ini yang you kena tentukan based on interpolation. Okay, so the easy way is 0.5 plus 0 divide 2, so you can get 0.25. So that is the average for the IZ. Okay, so we can see that there is a 3 groups of data. Okay, so 0.5 to 1.5, which is equal to 1.5 of difference or the change of the elevation. Okay, so 1.5 meter. Okay, so the average N, okay, 7.5, which is 6 plus 9 divided with 2, so they gain 0.5. Okay, then multiply with 7,666. Okay, then to get 5,745. Okay, so later on the average of the IZ, okay, the same procedure with the average of N, which is 0.5 plus 0.1 divided with 2 will become 0.3. Okay, then based on this equation, so the value for this equation is 0.000082. Okay, so that's why it will be more easy if you divide into 2. Okay, because the value is very small. Okay, so tak ada beza pun antara titik perpuluhan sampai this 4 decimal number. Okay, then you may plus the same, and then you get the cumulative value. So it's very tiny value. Okay, so then you repeat to calculate for the 1.5 to 4.5, 4.0. Okay, then 4.0 to 6. Okay, to get the other value for the IZ over ES delta Z. Okay, ada soalan? Ada soalan? Tak apa, sebarang soalan pun boleh. Tak ada? Tak ada eh? Tak ada pun cakap tak ada. Okay, tak ada. Okay, good. Okay, good. Tak perasan, sorry. Okay. Okay. So then we put this value, okay, in the main equation. Okay. So then we try to solve for the C1, C2, Q naught minus Q. Okay. So for the Q naught is the stress on the foundation, which is 167. Okay. While the Q, okay, is the stress from the surface to the base of the foundation, which is 18 multiplied with 1. Okay. So the C1 is 1 minus 0.5 Q over Q naught minus Q. So the value is 0.94. Okay. But the last one is the C2, okay, where it has an influence of the time. Okay. So then we get 1.34. Okay. So the total of the immediate settlement for the sand, okay, is 47 millimeter. Okay. So that is the SI for 5 years predictions. Okay. Okay. Ada soalan? Okay, pun tak ada. Okay, so then we proceed for the consolidation settlement. Okay. Saya tutup ni sekejap eh. Saya nak buka saya punya slide. Nanti attendance saya bagi dia punya QR code eh. Saya ada bagi tak slide kat e-learning? Hello.
Tak, doktor.
Ada. Okay, ada.
Ada.
Sekejap ni. Sekejap. Saya kena sebut sekejap. Sekejap ni. Okay. Sekejap. Okay. 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 Okay, so kita dah selesai untuk immediate settlement of footing on send. Okay. So nanti dalam awak punya for your assignment, okay, so there will be a question for the immediate settlement. Yeah, for the send. Okay. Okay, now we move to the consolidation settlement. Okay. So again, consolidation settlement, okay, only occur in a clay soil. Okay. So the behavior of this consolidation settlement, okay. So the relationship between times, okay, is a non-linear. Okay. So then once the soil, okay, experience the consolidation settlement, okay, then if we unload the soil from the loading, okay, so it will not back to the similar conditions before the loading, okay. So we consider as it is a irreversible behavior, okay. So definitely it is a time dependent during the consolidation settlement, okay. The longer times, okay, so the consolidation settlement, okay, will reach the full 100% consolidation, okay. So we need to know, okay, how long the process will be completed, okay. So in this case, okay, we may learn first how to estimate, okay, the process of consolidation, okay, and what is the value or the magnitudes, okay, of these deformations, okay, due to this consolidation settlement, okay. Beside that, we need to know, okay, what is the important consolidations properties and consolidation characteristic, okay. Seperti biasa ada soalan tanya Okay. Okay, this is a simple analogy on the consolidation settlement. Okay. So we just imagine, okay, that we have a cylindrical glass or perspective. Okay. Then, okay, the spring, okay, will behave as a soil fabric or soil skeleton. Okay. Then this valve, okay, we can imagine it is a drainage system. Okay. So when we apply a load, okay, on the top of this piston, okay, without open the valve, okay, so there will be no significant changes of the soil volume or these volumes, okay. So this we can say it is a immediate settlement, okay. So then when we open the valve and allow, okay, for example, if this cylindrical glass or perspex, okay, is full with air, okay, so this air will be uh, expelled out from this volumes, okay. Then we keep continue, okay, and then continue with a time, okay, which is allowed for this load, okay, to rest on the top of the piston, okay, and then until there is no movement happen, okay, later on, okay. So this is a simple analogy on the soil consolidation settlement, okay. So we just imagine the same situation, okay, when saturated soil is loaded, okay. So at the first load is taken by the water, okay, and then the water start to dissipate, okay. So the process of the load will be taken by the soil skeleton, okay? So up to a certain degree of consolidation, okay, the settlement will be stopped, okay, and we can see that it already reached the full consolidation settlement, okay. However, when we increase the load, okay, so the consolidation settlement will be continue, okay, and then again it will stop after a certain period of time, okay. So that is the process of consolidation settlement, or we can say as a primary consolidation. Okay. So how could we measure, okay, the consolidations properties, okay, of a clay soil, okay, and then this value we may use, okay, to estimate the settlement that will be occur on that or any particular site area, okay. So we may use this odometer test, okay. So we have another method, okay, they call as a row cell, or we have another method they call as control strain, control constant, sorry, CRS. Let me try to get it the full name first. Okay, they call as CRS, constant rate of strain test. Okay, so we have usually we have a 3 type of test, okay, where each test have different advantages, okay. So today we may discuss only on the odometer test, and it is a stress control test, okay. Sebab apa namakan stress control test, okay, because we rely on the load apply on the soil, okay. So nanti saya katakan detail what does it mean with the stress control, okay. So for example, we apply, okay, 50 kPa of stress, okay, on the soil for 24 hours. Okay. Then we increase double 100 kPa, okay, and on the same 24 hours, increase double 200 kPa and let it maintain for 24 hours, okay, until we stop up to 6,400 kPa, which is that is the capacity for the whole system of the odometer. Okay. Dia tak boleh lebih lah, kalau dia lebih dia akan terbalik ataupun terlampau berat. Okay. So that is for the odometer test. Okay. So now let me describe in detail, okay, what is the odometer test. Okay. So this is the setup, okay, for the odometer test. Okay. Okay. The size of the soil specimen, okay, is 50 millimeter in diameter, okay, 50 mm in diameter, and the thickness of the specimen is 220 millimeter. Okay. So ini 50 in diameter, okay, and 20, okay, on the height. Okay. Okay. So normally when we carry out for the soil investigation work, okay, so we may retrieve a soil sample, okay, where the diameter of the sample, okay, could be 75 millimeter or 50 millimeter, depends on the sampler tubes, okay. And then the height of the sampler tubes normally or usually is around 300 millimeter, okay. Okay, so then we need to cut or trim, okay, the sample, okay, to be fixed inside this odometer setup. Okay. So this sample, okay, will be overlain and underlain by a porous stone material. Okay. So this porous stone allow for the water to exit out from the sample, okay, during the loading process, and at the same time provide a rigid platform or rigid conditions during the loading process. Okay. So mungkin awak terfikir kenapa tak guna filter paper kan? Filter paper also allow water to expel out from the soil. Okay. Tapi filter paper ia tidak rigid ataupun dia tidak tidak memberi permukaan yang keras dan sekata. Okay. So that's why they use a porous stone. Okay. Where the stone has a pore. Okay. So this pore only allow for water to transmit, not the soil itself. Okay. Okay. So before the loading process, okay, the water, okay, will be filled up, okay, up to the top of the this odometer setup. Okay. So this confining ring, okay, confining ring, okay, is made from steel or aluminium, okay, and the process of consolidation, okay, is only allowed under a 1D, okay. So that's why in some textbook they call this 1D consolidation test, okay. Sebab dia hanya benar satu direction saja, deformation berlaku. Okay. Okay. So this is the setup for the sample. Okay. How to put the sample in the in this odometer setup. Okay. Yang ni tak ada apa-apa. Yang ni kita akan go through lah. Okay. So metering purpose of this allow water to flow vertically into and out of the source sample. Pressure is applied and dial reading. Okay. So during the testing, okay, when we apply a pressure, okay, then need to get or need to read or need to record, okay, the deformation value. Okay. So then normally it should be conducted in 24 hours. Okay. We should record the value and then plot the graph, okay, later on. Okay. Either using a logarithmic scale or we use a normal scale. Okay. So the procedure is repeated after sample reach 100% of consolidation. Okay. Then later on we increase, okay, the load double. Okay. So for each graph, the void ratio E and consolidation of the coefficient of consolidation that corresponding to the specific applied pressure are determined. Okay. So later on, I will show or we may discuss in terms on how to analyze the result from this odometer test. Okay, we try to gain the consolidation characteristic value. Okay. Okay, so this is the full setup. Okay, so this is what we the sample. Okay. In the odometer test sampler, okay, setup. So then the load, okay, actually this is the dead load system. Okay. So this dead load system later on will be divided with the area, okay, to get the value of the stress. Okay. While this gauge, okay, will be recorded during the testing, okay, and it will be convert to millimeter value, okay, to get the value for the deformations. Okay. So assumption that we should be made, okay. First, the soil either in the lab or at the site, okay, it is a fully saturated clay layer. Okay. So the confined ring, okay, will make the process of the loading is laterally confined. So when it's laterally confined, it will be a one-dimensional flow. Okay. So due to the loading process is very slow, okay, so it will behave as a constant permeability material. Okay. So then this assumption only could be measured by using this odometer test. Okay. Ada soalan? Ada soalan tak?
No from me, doctor.
No, okay. So no also from the other, okay. So kita teruskan ya. Okay. Okay. Macam mana kita nak record this consolidation process? Okay. When we apply a load, okay. Okay, normally we should two operator is needed. Okay. First, someone should record or log the time. Okay, and the other should record or read the dial gauge. Okay, to record the deformations value. Okay? And the time, okay, that has been stated in the standard, okay, so should begin with 0, okay, and then we should record at 15th second, 13 second, 45 second, and 1 minute. Okay. Then 2 minutes, 4 minutes, 8 minutes, 16 minutes. Okay. Then we continue to 30 minutes and then 1 hour. Okay, this is 1 hour. Okay. 2 hours, 4 hours, 8 hours, 16, and the last one will be 24 hours. Okay. So it means that when the 0, okay, is supposed to start with 0, okay, and then 15 seconds. So the other partner should read for the value for the deformations. Okay. So until up to 24 hours. Okay. That's why now we use the data logger. Okay. So data logger we recorded, okay, for every, for example, 15 seconds. Okay. Then we have a lot of data, okay, and then we doesn't need to stay at the lab, okay, to record the data. Okay, for example, if we start at 9 in the morning, so we need to stay, okay, almost at the night and then come back tomorrow again to record the data and then increase for the load. So by using the data logger, so we just record in the PC, okay, and then in the next following morning, so we increase the load. Okay. But for your case, for the undergraduate lab, okay, normally you need to record up to 100 minutes only. Okay. 100 minutes berapa jam? Almost 1.5 hours only. Okay. So the rest, it will be provided with a secondary data. Okay, then you need to come up with the all analysis to get the consolidation properties. Okay. So that is for a one single test, okay, or under one stress value. Okay. Then you may continue, okay. For example, okay, you start first with a very low value of loads, okay, or stress. Okay, kita mula dengan 3.125 kPa. Okay. Then we need to wait for 24 hours. Okay. Then we increase. Normally it will double, 6.25. Okay. Sama juga 24 jam. Then double, it will become 12.5. Okay. Then 25, okay, 50, 100. Nanti awak kira berapa hari semua terlibat. 200, 400. Alamak. 400. Okay, ni satu hari. 1, 2, 3, 4, 5, 6, 8. Dah 8 hari dah. Okay. 400. Lepas tu 800. 1,000. 600. 2,000. 3,200. 6,400. Okay. This is for the loading process. Okay. Then we will have a unloading process. Okay, nanti saya terang sebab apa we have unloading process. Okay, so then we try to reload. Okay, not 100% the same step with the loading process. Okay, but in a very not an extreme unloading process. Okay, so tak boleh lah daripada 6,400 then we jump to 400. Okay, so we need to have a very slow step of unloading. Okay, so ini mungkin boleh kurang daripada 800 then go for 400, then perhaps we can stop at 200 only. Okay, so this is the normal step, and then again we need to refer to the standard. Okay, while we cannot jump from 3.125 to 50, or we just start at 50 kPa. Okay, because the soil is very soft. Okay, so if we load to 50 kPa, okay, so perhaps the soil will be squeezed out, okay, from the piston plate. Okay, nanti kemungkinan soil itu akan terkeluar. Okay, that's why we need to load at the very low value. Okay, so that is for the procedure, okay, during the loading process. So imagine lah, 8 hari, 9, 10, 11, 12, 13, 14, 15, 16. Paling kurang 2 minggu 2 weeks. Okay. If you want to have a very full consolidation behavior. Okay. Nanti awak akan belajar, di situ awak akan tahu apa nama the full process, okay, when you carry out for the consolidation test. Okay. Ya, Okey. Tak ada soalan Senanglah jawab ni, semua cepat faham. Okay. So, coefficient of consolidation, okay, CV, okay, indicate how rapidly or slowly the process of consolidation takes place. Okay. So, the first step, okay, untuk setiap every stress yang kita apply, so we need to determine the CV value. Okay. So we should plot, okay, deformations over time, either by using a log scale graph or a normal graph. So suppose that we may have at least 14 hari, 14 series of different graphs under different stress value. Okay, so kita akan ada 14 graph. Okay, and then we also have at least 14 different CV value. Okay, kerana setiap stress yang dikenakan, CV value akan berbeza. Okay. Okay. So CV value indicates how rapidly or slowly the process of consolidation take place. Okay, and at the same time, this CV value could be used, okay, to determine how many minutes or years, okay, or month, okay, the process of consolidations will be completed. Okay. CV ni boleh menentukan berapa lama masa, okay, proses consolidation akan complete. Okay. So in order to plot for the CV value or to get the CV value, okay, either we use the log time method proposed or developed by Casagrande, or we use a square root time method developed or proposed by Taylor. Okay, ada dua Okay, so kita pergi satu-satu Okay. Okay. This is based on the Casagrande methods, okay, where we use the log time scale graph. Okay. So macam mana dapatkan nilai CV? Okay. First, we need to plot all the value that we gain, okay, from the consolidation test, okay, in this log scale graph. Okay. So for example, okay, pada bacaan 1, okay, because the limitation of this Casagrande, okay, definitely it could not start at 0 sebab mana ada log scale graph mula dengan 0. Okay. Or another way, okay, we can start at 0.1, okay, minutes, okay, which is not a very usual type of graph, because usually we start at 1. Okay, 1, 10, 100, 1000 means that the consolidation process or the testing stop, okay, up to 1440 kan. Mana 24 jam kan? This is 24 hours. Okay. So kita plot, okay, this blue line, okay, refer to the deformations over times. Okay. So we can obviously see what we call as three different curvature. Okay, curve 1. Okay. So this approximately a straight line 2, and this also this alamak. Okay. And this will be similar with the first curve from the first curvature line. Okay. Okay. So the first step is to determine the D100. Okay. Okay. This D100 represent, okay, where the process of consolidation for this value of stress, okay, completed, okay, during the consolidation process. Okay. Satu yang dinamakan sebagai D100. It means that the deformation under 100% of consolidation. Okay. So by using a tangent approach, okay, kita gunakan tangent approach. So kita draw what we call a 90 degree, and then approximate 90 degree. Then we draw a line, okay, which is represent the pink line, okay. And then the same approach, okay, where we draw a tangent line, okay, on the third curvature line, okay. Then it represent what we call as the green line, okay. So the intersection between the pink and the green line, okay, so we can consider as the D100. Okay. So kita ambil pembaris, kita lukis, okay, which is approximately tangent line to the second curvature line. Okay. So nak bina ataupun nak construct for the tangent line, okay, we should find where is the most what we call as the flat or the linear line. Okay. So then in that case we can approximately that is the 90 degree with the the second curvature line. Okay, and then the green line, okay, is constructed by referring to the third curvature line. Okay. Okay, then the intersection between the green and the pink, okay, is the D hundreds. Okay. Because the objective of this drawing, okay, is to get the value for the D50. Okay. So D50 cannot easily be obtained, okay, unless we get the D100 and D0, then we divide into 2. Kan? Maknanya D100 tolak D0, divide into 2, then we gain the D50. Okay. So that is for the D100. Okay. Then to gain for the D0, okay. Okay, ini awak kena beri perhatian. Okay. So for the D0, we need to choose for any point of time. Okay. For example, if we choose 2 minutes, okay, yang ni 2 minutes. Kita agak 2 minutes, but this is 1, and then the second will be 2. Okay. So this 2, we should multiply with 4. Okay. Then we get 8 minutes value. Okay. So this 8-minute value, okay, from the point of A, we should draw a horizontal line. Okay. And the same go to the 8-minute where we give a symbol of B. Okay. Then we draw a horizontal line on the B point. Okay. So the different distance between A and B, okay, we consider as an X. Okay. For example, if A to B is equal 6.2 minus 5.8, which is 0.4, okay, the same 0.4 we extend up from the A, okay. So we extend 0.4 as well, okay. So the extension of 0.4 from the A is the value of the D0. Okay. Okay. Faham? Kalau awak nak gunakan 8 pun boleh. Okay. Tapi pastikan awak nak guna 4. For example, 4. Okay. So 4 times 4 is 16. Okay. So then you need to draw the same procedure. Draw a horizontal line. Okay. And then try to find where is the 16. Okay. For example, ni dah 16. Okay. So then get the difference. Okay. X. Okay. Extend the same X. Okay. Then from there you can get the D0 as well. Okay. So that is the procedure, and then they have proof why we need I'm not sure either why they choose 4, okay, to multiply with 4. Okay. But I guess there's some mathematical operation, okay, why they choose 4, okay, to get the D. Why we should multiply with 4 to get the D0. Okay. So then the difference between D100 and D0, okay, which is 6.6 minus 4.4, then we divide into 2, okay, which is 2.1, sorry, 2.2, 1.1, okay. So then 6.6 minus with 1.1, it will become 5.5, okay. So then the value for the D50 is located at 5.5 in under the Y that exists. And then we need to get the vertical, we need to draw a vertical line, okay, to get the value for the T50. Okay, so for this case, the T50 we can say approximately around 16 minutes. Okay. Faham? Ada soalan? Tak ada. Soalan?
Doctor,
Ah,
could you repeat again how to get the D50
okay, D50
from the graph?
Okay.
Yeah.
Okay, this is D100. Okay, then we get the D0. Okay. So the difference between D100 and D0, we divide into 2. So that's why we call as a D50. So 6.6 minus 4.4, okay, it is 2.2, okay. So then 2.2 divide into 2, okay, it will become 1.1, okay. So 6.6 minus 5 minus 1.1, it will become 5.5, okay. So from the 5.5, we draw a horizontal line until it touch the consolidation curve, and then draw a vertical line. Okay, from there we can get the T50. Okay, for the time. While D50 is for the what we call as for the from the deformations value. Okay, boleh.
Okay, boleh. Thank you, Doctor.
Sama. Okay. So this T50 value, which is 16 minutes, okay, we should put or we should include in these equations, okay, to get the CV value. Okay, okay, 0.196 is the coefficients we call as a TV, okay, coefficient of time. Okay, while HD power by 2, okay, actually is the thickness of the material or the sample, and it is based on the drainage system. Okay, for example, for example, if we are using a porous stone, saya tulis dah PS, okay, on the top and on the bottom of the sample, okay, so it is behave as a double drainage system. Maknanya air boleh naik ke bawah, air boleh turun ke bawah. Okay. So if it is a double drainage system, this HD should be divided with 2. Okay. Okay. On the other hand, okay, if okay, the soil the soil is overlain, okay, by a porous stone and underlain with a hard aluminium plate. Okay. Maknanya aluminium plate air tak boleh penetrate ataupun transmit or moving out, okay, from the aluminium plate. So it's only allow for a one way or one direction of flow. Okay. So in that case, HD should be divided with 1. Okay. So apa maksud kedua-dua keadaan ni? Okay, you just imagine in the actual condition, okay, where the clay layer, okay, is overlain and underlain by a sandy soil. Okay. So kalau sandy soil, okay, water can transmit or move, going out, okay, going up and going down. So we consider as a double drainage. So in odometer, to replicate the same situation at the site, so then we use a double drainage system, which is the porous stone cover on the top end at the bottom of the sample. Okay. In the other situation, okay, let's say there is a bedrock. Ialah BD, bedrock. Alamak, sorry. Okay, bedrock. Okay. And definitely the rock is a fresh rock and it is a impermeable layer, okay, which is water cannot transmit inside this bedrock. So definitely it is a single drainage system. Okay. So the same where we want to replicate in this odometer. So we use the porous stone on the top and the aluminium plate at the bottoms. Okay. So that is very important for us to carry out for the soil investigation work. Okay. To identify what will be the formations of the soil underneath the ground surface. Okay. So this T50, okay, is for our case is equivalent to 16. Okay. And then we just imagine the HD, okay, is 20 millimeter. Okay. So the value of the CV can be easily get, okay, once we have determined the T50 value. Okay. Boleh lagi kita beri pada satu lagi CV value lah. Sebab so slow dah kot. Sebab puasa ni pun nak cakap pun sikit tekak. Sekejap Okay. Okay, this is for the CV by using another approach which is square root of time methods. Okay. So kalau sebelum ni kita menggunakan log time methods. So now we use the square root of time methods. Okay. So this square root of time methods, okay, we use a normal scale. Okay. However, okay, for each times that we recorded, okay, we should power by 2. Sorry, square root the time value. Okay, for example, 0, 0, 0 lah. Okay, then kita ambil lah 0.15 ataupun 50 second. Sorry, 15. Sorry, 15 second. Okay, so then we square root the value. 13 second, okay, we square root 1 square root, okay, until kalau kita guna minutes lah 114 we square root. Okay. So kalau case yang ini 16 16, okay, square root of 16, sorry, 16, alamak. Okay. So mana 16, okay, this is 16. Okay. So we power by 2. Okay. Berapa 16 power by 2?
256.
256 minutes. 256 minutes. Okay, so that is the actual minutes. Okay. But it's not up to 1440. Okay, 1440. Berapa value dah? 1440 square root. Actually 38. Okay, 38. So basically, yeah, it should cover up to 38 minutes. Okay. Sampai 38 minit lah. Okay, ni mana dia tak tunjuk the whole series of data lah ni. Okay. If up to 1440, so the graph should be plot at 38 minutes. Okay. So then kita plot as usual. Okay. after square root all the time. Okay. Then the first is to draw a tangent line starting from the zero value of the time on the graph. Okay. So it represents the pink line. Okay. Okay. The next step is to try to get any distance between the 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 y-axis, okay, to any point uh, on the pink line. Okay, for example, for this case, from here to here, for example. Okay, so we name as a D. Okay, then this D we should multiply with 0.15. Okay, and then extend it the same value with what we have multiplied with 0.15D. For example, if the D is equal to kita guna pembaris lah, 2 centimeter, for example, okay, then we multiply with 0.15. Okay, so it becomes 0.3, for example, okay, centimeter. Okay, then extend 0.3. Okay, so then we need to know we should draw another line, okay, from the origin of 0, okay, until it touch the extension line, the extension point, okay, and up to the x axis, okay, then they call as a Q. Okay, so this is P for the pink, Q is for the green. Okay, so the intersection between the green line with the blue line, okay, we call as a D90. Okay, kalau sebelum ni D50 kan, while this is D90. Okay, so from this D90, the same procedure, okay, you need to draw a vertical line, okay, and until it reach what we call as the the X axis. Okay, so for example, for this case, okay, the value for the T90, okay, D90 akan dapat T90 lah. We approximately as 6 for example 6, okay. Please do not use 6 because it is under a square root scale, okay. Then you need to power by 2, okay. Then the value for the time to represent the T90 is equal to 36. Okay. So berhati-hatilah. Maknanya awak kena pastikan awak power by 2. Okay. Kalau log tak ada issue sebab this is based on the log scale. So no need to, then you need to anti-log, okay, to get the actual value because it's already, we use the log scale. Okay, but for this case, we not use the square root time scale, but we square root the value of the time. Okay, then by power by 2, we get the actual times, okay, to represent for the time in the equation for the CV. Okay, so this T90, which is 36, okay, should be put in this equation. Okay, so this TV, okay, has been increased to 0.848, which is previously is 0.196, okay, because 0.196 is refer to the consolidation under 50%. Okay, so that's why this TV is equal to 0.196. Okay, nanti I will explain later on. Okay, how they get this TV value. Okay, while for this TV value, okay, because it is represent under 90% of consolidation, So that's why the value is a little bit high compared to the U50. Okay. So then we can get the CV value by using this square root of time method developed by Taylor. Ada soalan? Rasa kita stop sampai sini kot. Lepas raya sambung balik. Saya pun dah habis suara dah. Okay, ada lagi soalan? Tak ada Oh, laju awak Okay. Okay. So nanti saya terangkan how we appreciate the CV value okay, in the design. Okay. 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 So how do we get the factor 1.15? Okay, so this is how they derive. Why we should multiply with 1.15 or we multiply the D with 0.15. Okay. So this is how the derivation begin. Okay. So D50. Okay. Because we use the square root of time. So the value for the D50. Okay. It's sorry D90 square root by 0.484 lah, because the TV is 0.8 0.848. Okay, this is the factor of time. Okay, so D9 over 5. Okay, for the D50. Okay, and the same factor. Okay, which is 0.197. Jadi kalau sebelum ni 0.196 lebih kurang lah. Okay. So get the ratio, okay, between this value with this value. Okay. So from this ratio, we want to get the F. Sorry, we want to get what will be the ratio later on. So from there, they gain 1.15. Okay. So that is the idea why they multiply with 1.5 to extend the normal, the tangent line, okay, to the other new tangent line or new extension line. Okay. Okay. So square root of time versus log time method. Generally, square root of time method is better. Okay. Square root of time method usually give lower CV. Okay. As usual lah, kalau kita dalam design, normally we use the lowest value lah, okay, to become more conservative. Okay. Square root of time method easy to program in computer. Okay. K compute from CV almost always less than measure value, slower compression. K means that the permeability. We can also determine the permeability from the CV. Okay. To decide which is correct, compare the K value, okay, from the normal permeability test. Okay. So the square root of time method works well based on the assumption no secondary consolidation. Okay. Kalau tadi saya beritahu awak, kalau kita menggunakan this log time, okay, maknanya when it reach the D100, the rest will be the secondary consolidation kan. Sebab primary then continue with secondary. Actually, it doesn't occur any secondary consolidation because it's still under the range of the primary consolidation if only we consolidate for 24 hours. Okay, tetapi sebabkan kita menggunakan log time, kita boleh gambarkan adanya berlaku secondary consolidation. Okay. Used strictly for vertical drainage, okay, definitely. Cannot be used for some source such as pit. Okay, change very much when subject to change in effective stress. Okay, so only for clay, okay, while for the pit have a different discussion. Okay, because the pit contains a lot of organics. So there will be another consolidation process happen for the pits. Okay. Square root of time method is okay because the Zagi doesn't account for secondary compression anyway. Okay. So that is the argument made, okay, by several academicians, which is they prefer to use the square root of time compared to the log time methods. Okay. Okay. Ada soalan sebelum kita berhenti? Ada. Minggu depan ada kelas kan? Kawan nak buat kelas? Ada. Oh ada, nak kelas juga?
Nak cuti.
Cuti kan? Kan boleh pun cakap. Okay. So minggu depan kita cuti. Kita jumpa minggu satu lagi. Nanti saya terpaksa arrange masa sikit sebab saya kena pergi ke site untuk minggu satu lagi tu. Saya stop.